Because both of the pieces of this piecewise function are polynomials, we know that they will be continuous on their intervals. So we know already that from close bracket -1 to 3, and from close bracket 3 to 5, this function is continuous. The only thing we're not sure about is what's happening at 3. So in order to determine if this function is continuous at 3, we're simply going to look at limits. So the limit of this function as x approaches 3 from the left, we will need to evaluate in the part of the function when you have values that are to the left of 3, which falls into that first inequality. So when I do this, I'm going to be evaluating with x plus 2, and I get 5. Now let's look at what's happening on the right. So I'm looking for values that are to the right of 3, which would fall into this second expression. So I have 14 minus x squared. I'll substitute into that function, and I get 14 minus 9, which is also 5. So now that we see that the limit as x approaches 3 from the left and from the right is going to the same value, we can conclude that this function is continuous on the closed interval -1 to 5.